You are walking down a dark street, alone. Footsteps behind you. Your heart slams, your muscles lock. Before you've even decided to, you're already scanning for somewhere safe. Now imagine none of that happens. Not because you're brave, not because you trained yourself to stay calm, but because a small structure deep inside your brain has been quietly damaged. This is the reality of an extraordinarily rare condition called Urbach-Wiethe disease. In some people with this disorder, abnormal deposits gradually damage the amygdala, a pair of almond-shaped structures deep in the brain heavily involved in processing emotionally important signals, including many forms of fear. And one of the most remarkable people ever studied in neuroscience became famous because her brain offered scientists an almost impossible experiment. She is known in research simply as SM. Her amygdalae were severely damaged by Urbach-Wiethe disease. Scientists showed her frightening images. They exposed her to live snakes and spiders. They walked her through a haunted house. They studied how she reacted to threatening situations in everyday life. And again, something astonishing happened. She showed almost no fear. But here is where the story gets interesting. Because calling SM simply fearless is actually misleading. Fear is not controlled by one tiny switch in the brain. So what really happens when the brain loses a core part of its fear system? First, you need to understand the disease itself. Urbach-Wiethe disease, also known as Lipoid proteinosis, is an extremely rare genetic disorder. It's usually caused by changes in the ECM1 gene, which provides instructions for a protein involved in the structure and maintenance of tissues. The condition can affect the skin and other tissues. Some people develop characteristic skin lesions. Some develop a hoarse voice early in life, and neurological changes can occur as abnormal material accumulates in parts of the brain. In some patients, calcification affects the amygdala on both sides. Calcification simply means abnormal deposits containing calcium build up in tissue, making parts of the brain unusually hard and damaged. But here's an important scientific caveat. Not every person with Urbach-Wiethe disease develops the same brain changes. Some patients have amygdala involvement, some have other neurological findings. Severity varies widely. So the disease itself does not automatically mean someone becomes fearless. That distinction matters because the famous fear findings come from a much smaller group of patients with bilateral amygdala damage to both sides. And this is where the neuroscience gets fascinating. Your amygdala is not simply a fear button. Think of it more like an alarm and priority system. Your brain is constantly flooded with information from your eyes, ears, skin, memories, and internal organs. Most of it is not equally important. A cup on a table, probably irrelevant. A sudden movement in the bushes, potentially important. A car swerving toward you, extremely important. The amygdala helps the brain identify and prioritize emotionally significant information, especially anything connected to possible threats. So when that system is severely damaged, something fundamental shifts. A threatening event can still exist, but its emotional weight may not register the normal way. This was dramatically demonstrated through the work of researchers including Ralph Adolphs and Antonio Damasio, who studied patients with bilateral amygdala damage. One of their most famous findings involved SM. She had severe difficulty recognizing fear in facial expressions. Show her a face showing happiness, sadness, or anger, and she could usually name it correctly. But fearful faces were different. She did not naturally look at the eyes the way most people do. And that turned out to be crucial. The eyes are one of the strongest visual signals of fear. When researchers instructed SM to look directly at the eyes, her ability to recognize fear improved dramatically. Think about what that means. The problem wasn't that her eyes couldn't see fear. Her brain was failing to automatically flag the information that normally screams, "Something is wrong here." This discovery changed how scientists thought about the amygdala. Then researchers asked an even stranger question. Could the loss of amygdala function affect fear itself, not just the recognition of it? In a landmark 2011 study, Justin Feinstein and colleagues tested SM under conditions designed to provoke fear. They showed her frightening films. They exposed her to live snakes and spiders. They took her through a haunted house, and they tracked her responses over an extended period. The result was remarkable. SM showed almost no conventional fear response. She didn't just report being less scared than average. Across every situation, her fear, both reported and observed, was profoundly reduced. Yet she could still experience other emotions. She could laugh, she could become angry, she could feel sadness, she could form relationships. This was not a person with no emotions. It was something far more specific. Her brain had lost a key piece of the machinery that normally converts certain threats into the conscious experience of fear. And that creates a strange paradox. If fear protects you, what happens when it disappears? At first, it almost sounds like a superpower. No fear of snakes, no fear of haunted houses, no fear when someone tries to intimidate you. But fear exists for a reason. Your body reacts to danger before you've had time to think about it. A car suddenly swerves toward you. You jump back before you've consciously registered why. An explosion goes off nearby. Your attention locks onto it instantly. A stranger turns hostile. Your body is already preparing to run or defend itself. Fear is uncomfortable, but discomfort isn't always the enemy. Sometimes it's the warning system keeping you alive. And this is where the real danger of amygdala damage shows up. A person with severely impaired fear processing may walk straight toward situations most people instinctively avoid. That doesn't mean they can't understand danger intellectually. This distinction matters enormously. You can know a snake is dangerous without actually feeling afraid of it. You can understand a dark alley is risky without experiencing the alarm that normally pulls you away from it. Knowledge and fear are not the same thing. Researchers have found evidence that people with bilateral amygdala damage can show profound abnormalities in how threatening information gets prioritized. But there's another twist. The amygdala is central to fear, but it isn't the whole fear system. Researchers have found situations where people with bilateral amygdala damage still experience panic. One striking example, inhaling a high concentration of carbon dioxide. That experiment triggered genuine fear and panic in patients with bilateral amygdala damage. Why? Because the brain can detect internal bodily danger through completely different systems. Your body is constantly monitoring carbon dioxide, oxygen, breathing, and blood chemistry. So fear isn't one switch. It's a network. The amygdala is a major node in that network, but not the whole network. This gives you a much clearer picture of what Urbach-Wiethe disease actually teaches us. The brain does not have one single place where fear lives. Fear emerges from communication between multiple systems. The amygdala assigns emotional importance to threats. Other regions interpret the situation. Your body generates the physical response. Your memories provide context. Your conscious mind stitches it all together. Remove one major component, and the entire experience can change. But Urbach-Wiethe disease teaches something else too. Your brain is remarkably adaptable. Some patients with amygdala damage perform surprisingly well on many cognitive tasks. They speak, they remember facts, they solve problems, they interact socially. The damage doesn't erase the mind. It selectively alters one specific channel of emotional processing. That's exactly why rare patients like this are so valuable to neuroscience. Scientists can't ethically remove a brain structure from a healthy person just to see what happens. But rare diseases sometimes create natural experiments, and those natural experiments reveal relationships between brain and behavior that would otherwise stay hidden forever. SM became one of the most studied people in the field. Her case helped scientists understand not just fear, but attention, social perception, threat detection, emotional learning, and how different brain systems cooperate. And there's one last misconception worth destroying. Urbach-Wiethe disease does not create a fearless superhero. Fearlessness sounds powerful in a single sentence. In real life, the absence of fear can be dangerous. Fear doesn't guarantee your safety, but it shapes your behavior, often before conscious reasoning even catches up. That's why fear isn't something you should want to eliminate. It's information. Your brain is constantly asking one question: is this important? Sometimes the answer is no. Sometimes the answer is run. Urbach-Wiethe disease gives scientists an extraordinary glimpse of what happens when one of the brain's major threat processing systems goes dark. And the answer isn't that you become fearless. It's much stranger than that. You may lose the emotional alarm that makes certain dangers feel urgent. You may still understand danger intellectually. You may still feel other emotions fully. And your brain may still detect some threats through entirely different pathways. That's the deeper lesson here. Fear is not weakness. It is one of the most sophisticated survival tools your brain has ever built. So the next time your heart suddenly races because you heard something behind you in the dark, remember what that feeling actually is. It is not your brain making you weak. It is your brain quietly telling you that something matters.